Here we'll do some practice using our uniform motion equation. So press pause and do your best to work through this, and then press play and we'll go through it together. So first of all, this is going to be one of the last times we deal with miles per hour. Pretty much after this, we're going to always be talking about meters per second. But let's try to identify these values that they're giving to us. So the 70 miles per hour, that's our velocity. You might think, oh, but it says speed. But in this case, we're going to kind of ignore that you're turning or changing directions. We're going to treat this as a uniform motion problem. So we're going to treat this value as our velocity, and the displacement is 320 miles. That's the we could say it's the distance we traveled, because again we're going to assume we're not really changing direction, but for our purposes we can consider that the displacement is 320 miles, the velocity is 70 miles per hour, and they're asking how long. So here I've kind of identified the variables that I use in my equation. There's my delta x, I write out what it is. There's my velocity, I write out what it is. And I always like to write down the variable that they're asking us for. Delta t is the variable we're trying to solve for, so I put equals question mark. So now that I've identified these variables, I can use my equation. This is our very simple uniform motion equation. You can only use this when there's no acceleration. And now we just plug in the numbers and we chug through the math, and we find that our time is 4.57 hours. How do I know that that's the time? Or how do I know the units are hours? That's because my velocity was miles per hour. So my time unit here is in hours. Let's do another one with more standard physics units. So again, press pause, take some time to read through this, and then press play when you're ready to solve it with me. I'm going to start the same way. I'm going to try to identify the variables that I am being given or that I'm being asked for. So we know that our velocity is 5 meters per second. They tell us it's constant, so we can use our uniform motion equation. The object is traveling with this velocity for 7 seconds, and they're asking where will it be. So they're not exactly saying what is the displacement, but my displacement is, if I calculate what the displacement is, that's going to let me calculate where it will be, because really the where it will be is like asking for x final. And because they're saying 7 seconds after it was in the position x equals 2 meters, this is like my x initial. So if I solve for delta x and I know what x initial is, I'll be able to figure out x final. So I'm still going to use this form of the equation just because that's the one I'm comfortable with. I can plug in the numbers and I can find that its displacement is 35 meters. Now that I know the displacement is 35 meters, I can figure out where it will be if it started at a position of x equals 2. This is my x initial, so that's what I plug in for x initial, and x final is what I'm trying to solve for. So as you look over these two very simple examples, these are way too easy to be on a quiz. Way too easy to be on a quiz. We're going to build to things that are much more complicated. But for now, what I want you to get out of this example is the process of taking the information that we're given and connecting that to the variables that we see in our equations, because a lot of times that's one of the hardest things for us to do.